at the top, we have a few vocab words to define here. Space is defined as the set of all points. Space is known as the set of all points. Geometry is built on BUT terms, BUT standing for basic, undefined terms. They're not going to be mathematically defined. I can't define these words with other math words. They're basic because we all pretty much already understand the three BUT terms. The first one, sorry you guys, this color drives me insane, being point. Your first basic undefined term is a point, and it's defined as a location in space. Since space is made up of all points, the set of all points, then a point is just a location in space. You're welcome. Points have no size, really. I mean, I might draw them on the boards, one bigger than the other one, but we just have to remember they're technically all the same. And when you name one, you name it using a capital letter. Points use capital letters. So this is point A, point E, point Q. I use capital letters. On the whiteboard, I have another point Q and a point P and a point U and a point T. And if you have really good eyes from last year, you can see I still have point X way over here on this yellow poster. Capital letters name points. They're locations in space. These four magnets, points. It's a location in space. The eraser of your pencil, like a point, location in space. The tip of the flagpole, point. The sprinkler heads, points. The speakers, points. They're all locations in space. Some are bigger than the other, but we just have to try and think, oh, they're all the same. Okay. Second undefined term is a line. And the best way to describe it is a series of points that extend in opposite directions without end. Without end means they go on forever. Lines do not stop. They go on forever. Since space is made up of all the points, I have a point here and a point here and a point here and here and here. And there's more points in between these points because there's points all over. And there's even more in between those ones. And these series of points are so close together that they're starting to represent a what? A line. Good. Lines have to have arrows on the ends of them. What do you think the arrows indicate? They go on forever. Lines go on forever, so they have to have the arrows. Pretty sure your picture to the right has an A and a B, correct? Okay. Those are just two of the points that are on the line that I named. So we can name it line AB. You would pick 2 points from it, and then you name it line AB with a little symbol over it. Up here on the whiteboard, T and U are 2 points from this line, so it's line TU. You have to make sure you put that symbol over it. Tomorrow we're going to learn more symbols, so we got to make sure we're using the right ones. Your last BUT term here is a plane. And a plane is a flat surface that has no thickness. It's two-dimensional. Planes are two-dimensional. They're flat surfaces. They contain lines, which means they contain points. And planes go on forever. They extend without end, so they go on forever too. The piece of paper you're writing on would represent a plane. It's a flat surface. The whiteboard, it's a flat surface, it's a plane. Your desktop, this tabletop, flat surface, it's a plane. The ceiling is a plane. The floor is a plane. The walls are planes, flat surfaces. I'm just thinking about the fronts of them because they're two-dimensional. There's no thickness to them. One way to name a plane If it has points right on it, then I can just name this plane ABC. There's a couple different ways, and we'll get to those later on. So we got points, lines, and planes. Planes and lines go on forever. A couple other definitions here. Collinear. Prefix co means with, together, joint. And then linear, what word is in linear? Line. So we have to think about points that are collinear. And co means with, and together, and joint. And linear means line. What do you think collinear points are? Collinear. Co means with and together and joint, and linear means line. Caitlin? Points with lines? Sort of. Well, every line has points on them, right? Sorry, I'm gonna kick your bag. You're kind of on the right track. Something specific about the points. They're on the same line. They're with the same line. Collinear points are points on the same line. Collinear with the same line. Collinear points on the same line. So if collinear means on the same line, what do you think coplanar means? Excellent, on the same plane. Coplanar is defined as on the same plane. You can have coplanar points, and you can also have coplanar lines. We would say things like if they're not collinear, then we call them non-collinear, which would mean they're not on the same line. And you can have non-coplanar, not on the same plane. So we just put the word non in front of it. Collinear, on the same line. Coplanar, on the same plane. This next blank is kind of redundant. It says that 2 points or lines are coplanar if they are on the same plane. Last vocab term for today is a postulate. And postulate is kind of just a fancy word for rule. In geometry, postulates are rules that we accept without proof. Or you could state that as an accepted statement of fact. I can give you the postulate, the rule, and I don't have to explain why. I don't need to give you reasons why. I don't have to prove it to you. It's just a rule that you have to follow. The postulates that are in your geometry textbook would be the same postulates that are in the geometry textbook at O'Gorman, which are the same ones in Pierre and in Rapid City. Geometry has the same postulates. And they're all the same rules that we follow in geometry. We're going to learn the first 4 today. So in that little box there, 3/4 of the way down, postulate 1-1. Through any 2 points, there is exactly 1 line. 2 points will always make 1 line. Sprinkler head to sprinkler head. I can connect those with a string, and the string is representing my line. Sprinkler head to sprinkler head back there. I can connect those 2. There's my line. Any 2 points will make a line. I could go from the point, that corner in the room way over there, all the way down to this corner by the door, that's a point, and I'd have a string going diagonally through my room, a line. 2 points make 1 line. In your little picture here, it says line T is the only line that passes through which 2 points? Don't be shy. A and B, good. Side note, this line, if I use 2 points from it, is called line B. Line AB. If there's a lowercase letter, then you may also use the lowercase letter to name it. Line AB and line T, that's the exact same line. Sometimes there's a lot of information on the paper and you don't need it all. I don't know why they do that to you. So first rule of geometry, 2 points make a line. Second postulate, if 2 lines intersect, then their intersection is exactly 1 point. If the lines are going to intersect, if they cross, they will only meet at 1 point and 1 point only. So here I have line AE and line BD, which intersect at what? C, good. If 2 lines intersect, then their intersection is a point. Notice that A, B, E, and D, they have those nice points for you, but C doesn't. If there's intersections, you're probably not going to see a dot next to it. Because this theorem, or excuse me, this postulate just tells you if they're intersecting at a point. So without having to draw this here, we know it's a point. Every intersection of 2 lines is a point. All the ceiling dividers, this line intersects this line at this point. The lines in the bricks, this vertical line and this horizontal line are only intersecting right here. They're never going to cross in another point. If lines intersect, their intersection will be 1 point. Third postulate, if 2 planes intersect, then their intersection is a line. Planes are flat surfaces, so the ceiling and the front wall, those are my 2 planes. They're intersecting, they're hitting each other. And they start way back in that corner, and they go all along this line. Sissy Bright is not going to like me today. That entire line is their intersection. That's where they meet, that's where they touch, that's what they have in common. The front wall and the floor, 2 planes that intersect all along this line. If 2 planes are going to intersect, they must intersect at a line. They have to. In your picture here, plane RST and plane STW intersect at which line? Good, Morgan, ST. Their intersection is this whole line, ST. A lot of geometry, postulate, and theorems you'll get to, but they're also rules, are written in if-then statements. If 2 planes intersect, the intersection is a line. If 2 points intersect, 2 lines intersect, then their intersection is a point. You have to watch that. If 2 planes intersect, do planes have to intersect? Gavin, do they have to intersect? Weren't you shaking your head no? No, you weren't? Or yeah, you were. Yeah, you were. 2 planes don't have to intersect. The ceiling and the floor, do they intersect? That'd be bad if they would, wouldn't it? Yeah, we'd call them parallel. So if planes intersect, then their intersection must be a line, but they don't have to. We'll get further into that if-then stuff, but you'll see that a lot. Last rule, last postulate today. Through any 3 non-collinear points, there is exactly 1 plane. So we all know how many 3 is. Non-collinear, what does that describe about the points? Non means not. I already got that part. Grant? Good, they're not on the same line. So here's point A, point B, and point C. Definitely can't connect those all with 1 line. Those 3 points, though, will make a plane. They will make a flat surface. One at the bottom says in the figure, name 3 points that are collinear and 3 points that are not collinear. Your X, Y, Z, and W, those are supposed to be capital letters, but M is lowercase, sorry. Doesn't look like it very well. So in this image, in this diagram, you need to find 3 collinear points and then find 3 non-collinear points. Nathan, what's it mean to be collinear again? Did you find 3 collinear points? Did you use letter M? Good. What'd you come up with? Awesome. 3 collinear points. They're all on the same line. Ross, if collinear is on the same line, then what's non-collinear? Good. Can you give me 3 non-collinear points from this diagram? Z, X, Y. Good. Nicole, can you give me a different set of non-collinear points? Can't use M. That's not a point. It's in lowercase letters. Excellent. X, Y, W. Zach, can you find a third set? Oh, I already have that one over. Here, it's W, X, and what else? That we haven't used. Good. Those are 3 sets of non-collinear. You only needed to list one of them. And then you have 1 set of collinear. When you list something, guys, name 3 points, list 3 points, make sure you put those commas in there. If you're listing like your favorite foods, you wouldn't just list orange, apple, banana, pizza, you'd have to put a comma between them all, right? When you list things, you put commas. Good. Number 2. You can name a plane using any 3 or more points that are on that plane. We're going to show a bunch of different names for this one plane. Doesn't matter where you start. You just have to make sure you make a full loop around. So I could call this plane RUTS. I don't have to put the word plane in front of it. I just take the 4 letters and name it. I could start at R again and go the opposite direction. And then the name of this would be RSTU. Still the same plane, just naming it differently. I could start at T and go clockwise around. I have to make sure I stay in that circle and come back. Oops. T, S, R, U. Those are 3 different names for the same plane. Start at 1 letter, start at 1 vertice, start at 1 corner, and then just make sure you loop around. You can't hop, skip, and jump around. You don't have to use 4, but you must use 3 letters. So you could just name this STU if you wanted to. Good luck. See ya. Grant, you wouldn't want to put commas in these ones, though, because they're not listing points, right? You're naming it. And we don't put commas between G and R and A and N and T, right? Good. When you name something, don't put commas. You don't put commas in your own name. When you're listing something, that's when you use commas. Questions on the first 2? Cool, flip it over. At the top, it's asking us for the intersection of plane HGC and plane AED. From our 4 postulates, one of them says that if planes intersect, then their intersection must be a what? Point, line, or plane? If 2 planes intersect, then their intersection is a line. Good. So we know that this, if they intersect, must be a line. Shading, highlighting, tracing over will be beneficial here, I think. Plane HGC. HGC is actually the entire back or front, depending on how your eyes are adjusting, of this prism. They didn't include the letter D in the name, but we need to understand that it still gets included with the plane. So plane HGC is the whole backside there in blue. Plane AED. Again, they're only listing the 3 letters, but we need to include H. We just need to know that and understand that. That's our left side. Where does plane AED and HGC intersect at, Grant? Good, line HD. Or DH, however you want to write that. When you trace over it, especially if you have two colors, wherever the two colors are, there you can see that that's the intersection. Or if you shade it in. Two planes, if they intersect, will always intersect on a line. I'm going to skip that next little paragraph thing. We're just going to go to number 4. Number 4, part A. Shade the plane that contains X, Y, and Z. Haley, what shape did you shade in? A triangle? Good work. My picture is not exactly like yours, but you should have shaded in a triangle. Part B asks if points W, Y, and X are collinear. What do you think, Peyton? No, good. Definitely not collinear. There's no way that I could take like a ruler and connect all 3 of them at one time. Peyton, would you say that they're coplanar? Yeah, they are. Good. They're all on that bottom plane. They're just not collinear. Number 5. Your picture to number 5 is to the right of the pyramid that you just did, where those 3 lines are intersecting. The first part says, using the picture, name line M in 3 different ways. So I think your M kind of got cut off, but you should be able to find it. I highlighted it up here on the smartboard. Name line M 3 different ways. Brad, do you have another name for line M? I just didn't hear you. Okay, you know that first postulate, how many points does it take to make a line? So just give me 2 points. Excellent. Line EC, that's another name for line M, because point E and point C are both on line M. Ross, can you give me a different name for line M? Excellent, line EF. Because those 2 points are also on that same line. Poppinga? What? Find me the third one. Another name for this line. Like Brad gave us EC and Ross gave us EF. There's one other name. Excellent, line FC. Or CF, it wouldn't matter the direction those letters are in, or order, I guess I should say. Those are 3 different names for the same line. Wilford. Line N, can you name that one differently? I just didn't hear you. Good, line DC. Because D and C are both on that line, so I can rename it using line DC. Line L. This one right here. Taylor, what's another name for line L? PD, good, line PD. Logan, what's another name for line L besides line PD? DE, excellent, line DE. And we could do line EP if we wanted to. Good. Multiple ways to name lines, right? If there's a lowercase letter, then you can use that. Otherwise, you have to pick 2 points from it. We already talked about the second part. Why do we use these arrowheads? What do those indicate? They keep going. Good. The arrows remind us that lines keep going. That's the difference between a line and a segment when we get there. Arrows mean they go on forever. One way to name this plane is plane Z, because that's the letter on the inside. Give me 3 other names for it. Brooke, what's one name for it? Did you say HEFG? Good, there's one name. Marcel, what's another one? Good. Siegfried, I need a third one. Awesome. There are a lot more, but those are just 3 of them. You must use 3 letters, so if you just did like HGF, that would work. But you can use 4. Number 7, name 2 planes that intersect at line BF. Here's line BF. We have to find the 2 planes that share that line, that connect there, that meet there, that are intersecting right there. Or you can kind of think like what parts of the box? Is it the top and the bottom? Is it the left side and the back side that are hitting right there? Which two planes intersect there? Caden, did you get one? Or either? GFBC, okay. What's your other one then? Is that what you said? Would those two intersect on my blue line? They'd intersect on FG, wouldn't they? Okay, so what's my other one that intersects there? Good, EABF, excellent. Good. When you look at the names of them, if you use all four, you can see that F and B are the only two letters that are in common, so they're going to intersect at that line. Image, you can see it looking at the picture then. Skipping 8, go to 9. Part A, Riley J. Name 3 collinear points from this prism. What's collinear mean? On the same line. So you have to find 3 points that are all on the same line. Three of them, D, H, and what? Good. Those are 3 collinear points. They're all on the same line. I want to skip the next two. I want to go to D before the bell rings here. How many planes contain points A? The top E is an F. Yours, you have 2 E's, I'm sorry. The top one is an F and H. I have to figure out how many planes contain those 3 points at one time. So it's not 9 planes. There aren't 9 planes that pass through those 3 points. I want to know how many planes pass through those 3 points. This actually comes from section 1.2, which we didn't do, but I think we'll be okay. It says, prove that this statement or conjecture is false by finding a counterexample. Our statement states that 2 planes always intersect in exactly one line. You have to give me a situation where this is not true, where 2 planes will not always intersect in one line. What do you mean? You mean like the west wall and the east wall? What kind of planes are those? Excellent, good. Your counterexample would be parallel planes. The key word here that you were trying to disprove is always. 2 planes don't always intersect. If they intersect, they'll intersect on a line, but they don't always have to intersect. Good. I think you have enough to go off of for your homework assignment.